What power is required per kilometer of a line to overcome the viscous resistance to the flow of glycerin through a horizontal pipe of diameter 100 mm at the rate 10 liter per second? So liter L per second means liter per second. Liter per second is a unit of discharge. So here discharge through horizontal pipe is 10 liter per second. Take dynamic viscosity as 8 poise and kinematic viscosity as 6 stokes. Here 8 poise. Poise is a CGS unit of dynamic viscosity. Dynamic viscosity ki poise అనేది ఏంటంటే ఒక CGS unit. And what about stokes? Stokes also a CGS unit of kinematic viscosity. Kinematic viscosity ki CGS unit stokes అనేది. Okay. So anyhow, here we need to find power required per kilometer of a pipeline. Actually given line, but we can say pipeline. It's a pipeline. So okay, so per kilometer of a pipeline to overcome the viscous resistance. To overcome the viscous resistance. And remember, viscous flow is also known as laminar flow. Viscous flow is also known as laminar flow. Okay, na? So anyhow, first of all, let us note down the given data. Here the fluid is glycerin. Okay, here fluid is glycerin. So through a horizontal pipe, diameter is 100 mm. So there is a horizontal pipe. There is a horizontal circular pipe in general. So through which the glycerin is passing through this horizontal pipe. Glycerin. Here fluid is glycerin. Okay. Given diameter of the pipe. Diameter is equal to 100 mm. Given diameter of the pipe. So diameter of the pipe is 100 mm. And discharge is also given. Discharge 10 liters per second. 10 liters per second. We know that 1 liter is equal to 10 to the power of minus 3 meter cube per second. So 10 into 10 to the power of minus 3, 10 to the power of minus 2 meter cube per second. And next given dynamic viscosity. Dynamic viscosity denoted by mu. Mu means dynamic viscosity. Here dynamic viscosity 8 poise. And 8 into 1 poise is equal to how much? 1 poise is equal to 10 to the power of minus 1 Newton second per meter square. Newton second per meter square. So 1 poise is equal to 10 to the power of minus 1 Newton second per meter square. So 8 into 10 to the power of minus 1, 0.8 Newton second per meter square. This is SI unit of dynamic viscosity. SI unit of dynamic viscosity. Okay, అన్ని కూడా మనం SI unit లో కన్వర్ట్ చేసుకోవాలి. ఓకేనా, స్టాండర్డ్ యూనిట్స్. నెక్స్ట్ mu is given, kinematic viscosity. Kinematic viscosity mu is equal to, so how much is given? Given how many stokes? Given 6 stokes. 6 stokes. 1 stoke is equal to 10 to the power of minus 4 meter square per second. So meter square per second is a SI unit of kinematic viscosity. This is CGS unit. This is SI unit. Okay. Anyhow, 1 stoke is equal to 10 to the power of minus 4 meter per second. Okay. So nu is equal to 6 into 10 to the power of minus 4 meter square per second. So ultimately what we need to find? So we need to find power required per kilometer of a pipeline. Kilometer per kilometer. It means length of the pipeline how much? Length of the pipeline is 1 kilometer. Per means 1 per kilometer, 1 kilometer. 1 kilometer is equal to 1000 meters. Kilo means 1000. Thank you. So L is equal to 1000 meters. Now we have all the data. Okay. So we need power required per kilometer to overcome viscous resistance. Viscous resistance. So we have to find power. So anyhow, what is the formula for power? Power is equal to, okay na? So general formula, rho g q hf by 1000. So rho g q, rho means density of glycerin. Here rho means density of glycerin. Rho g, we can take rho g, or directly rho. You can take rho, no problem. Rho means density of glycerin. G means acceleration due to gravity. Q means discharge. And HF means head loss due to friction. So head loss due to friction. What is the head loss in this pipe? Due to friction. Okay, na? So there is a friction between the fluid layer and pipe surface. Okay, so that value, we need that value. First of all, here we need HF and rho. So ikkada manaku kavalsindi density of glycerin to find power. So we need density of glycerin, and at the same time we need head loss due to friction. Okay, we know that. What is the relationship between dynamic viscosity, kinematic viscosity and density? So density of glycerin, we need density of glycerin. Here rho means density of glycerin. Density of glycerin. So first of all, kinematic viscosity is equal to dynamic viscosity by density. So kinematic viscosity formula, dynamic viscosity by density. So we need density. So density is equal to how much then? Mu by nu. From this formula, it can be written as rewritten as rho is equal to mu by density. I mean nu. So here mu how much given? Mu value 8 into 10 to the power of minus 1 by mu value. So given how many stokes? 6 stokes, and 6 into 10 to the power of minus 4 meter square per second. So density you will get how many kg per meter cube? You will get density as density value. So I just calculated. So if you calculate, you will get density as 8 by 6. 8 by 6 means 2 3s, 2 4s. 4 by 3 into 10 to the power of, if 10 to the power of goes to numerator, it becomes 10 to the power of plus 4. 10 to the power of plus 4 into 10 to the power of minus 1, 10 cube. So rho is equal to 4 by 3 into 10 cube. 4 into 10 cube means 4000 by 3 kg per meter cube. You will get rho is equal to 4000 by 3 kg per meter cube. Now, in case of viscous flow, given viscous resistance or laminar flow, head loss due to friction, HF is equal to what? HF is equal to 32 mu u bar L by rho z d square. This is the formula. 32 mu u bar L by rho z d square. Here mu bar means average velocity, okay, na? And L means length of the pipe, and mu means dynamic viscosity, rho density of glycerin, G for specific gravity, acceleration due to gravity, and D means diameter of the pipeline. So diameter how much you given? Given D is equal to 100 mm. Of course you already given 100 mm. Okay. Next, 100 mm is equal to how much? 0.1 meters. And next, mu already given. Mu is equal to dynamic viscosity how much? 0.8 into 10 to the power minus 1 means 0.8 newton second per meter square. And how do we get mu bar? U bar means what? Average velocity. What is the formula for average velocity according to continuity equation? Average velocity U bar is equal to discharge Q by area. Discharge by area. So discharge. So given 10 liters per second. So 10 into 1 liter is equal to 10 to the power of minus 3 meter cube. Okay, per second. So 10 to the power of minus 3 meter cube per second by second. Okay. Area. So area of a circular pipe, pi by 4 into d square. What is the diameter? 0.1 whole square. Okay. So anyhow, u bar is equal to, if you simplify this, you will get 10 into 10 to the power of minus 3, pi by 4, because reciprocal of pi by 4, 4 by 5. So 4 by pi into 0.1 whole square can be written as, so 10 to the power of minus 2. Okay. So u bar is equal to, here we have 4 by pi into 10 into 10 to the power of minus 2, you will get minus 3. You will get 10 to the power of minus 2 by 10 to the power of minus 2. 10 to the power of minus 10 will get cancelled. 4 by pi. If you calculate, you will get approximately 1.273 meter per second. So average velocity 1.273 meter per second. See here a power m into a power m plus n. 1 minus 3 means minus 2. 10 power minus 2 by 10 power minus 2. They get cancelled. You will get u bar as 1.273 meter per second. Okay. So now we have average velocity and remaining all things already we have. So substitute all the values, you will get head loss due to friction. Now HF is equals to 32 into dynamic viscosity 0.8, average velocity 1.273, L 1000 meters, 1 kilometer 1000 meters by density of glycerin. We got 4000 by 3 into acceleration due to gravity 9.81, d square, rho g d square, d value 0.1 whole square. HF is equals to, so reciprocal of 4000 by 3, 3 by 4000, so 3 into 32 into 0.8 into 1.273 into 1000 by 4000 into 9.81 into 0.1 whole square. 0.1 whole square. 3 zeros get cancelled. 4 ones and 4 eights are 3 eights are 24. 24 into 0.8 into 1.273 by 9.81 into 0.1 whole square, 0.01. If you simplify this using scientific calculator, you will get this value as 249 point. I got 249.15 meters. So head loss due to friction in the pipe is 249.15 meters. Okay. So now we have head loss due to friction and density of glycerin. Let us find power loss due to friction. The amount of power required to overcome viscous resistance, or simply we can say that power loss. Amount of power required to overcome viscous resistance is given by, what is the formula? Rho g q hf by 1000. So P is equal to, rho means density of glycerin, how much? 4000 by 3 into acceleration due to gravity 9.81. Discharge how much? Discharge value, how much is given? 10 liters per second, so 10 into 10 to the power minus 3 meter cube per second. Head loss due to friction. Head loss due to friction. How much we got head loss due to friction? Into head loss due to friction, we got 249.15 meters. Okay. So first of all, 1000 ones, 1000 fours. P is equal to 4 into 9.81 into 10 into 10 to the power minus 3, 10 to the power minus 2 into 249.15 divided, okay, already okay, 1000 ones, divided by, here denominator 3 is there, 3. P is equal to, if you calculate this value, 4 into 9.81 into 10 to the power of minus 2 into 249.15 by 3, you will get the final value as 32.5 kilowatt. Okay, now if you calculate, you will get this value. So there